Okay, so let's go ahead and take a look at this lesson. So this is a review. So I want to look at just kind of a mixture of things. So the one thing that I want to look at here is I just want to remind you guys about, increasing and decreasing. And I understand that for the most part, you guys have seen this before. It makes sense to you, but I need to reintroduce some vocabulary to you. So when you look at the equation of a line, and you look at your slope here. The slope being positive will tell you that the function is increasing, and then the slope being negative tells you that it's decreasing. So this function is increasing because the slope is positive. Okay. And I'm going to do all the odd numbered questions, and then I'll leave the even ones for you to do. Okay, so find the slope that passes between these 2 points. So I'm going to go ahead and find slope. So that is, let's go 2 minus 4, and then this is divided by 5 minus a negative 1. So then I get a negative 2 over 6, which is negative 1/3. Okay. We are going to talk about slope, and so that's why we're doing this review of slope and writing the equation of lines, which is what we're about to do here. I want to write the equation of the line through these 2 points. So this is in function notation, so remember that inside that parentheses is the x values, and then the y values is what it's equal to. So when I find my slope is equal to 2 minus a negative 4 divided by 5 minus a negative 5. So I get 6 over 10, which is 3 over 5. Now, when I write the equation of the line, what I'm going to do is I'm going to write it in point slope form, which is y minus y1 is equal to m times x minus x1. And so I'm going to pick whatever coordinate point I want. It doesn't make any difference which coordinate point I pick, because if I were to distribute both of them and turn it into y equals mx plus b, which is slope-intercept form, I would get the same function unless I made a mistake. So I'm going to just choose the first one. So y minus a negative 4 is equal to 3 over 5, x minus a negative 5. So then I get y plus 4 is equal to 3/5 x plus 5. And I'm going to go ahead and leave it in point slope form. Okay, so you guys will see, I'll put things in slope intercept form when I have no choice. So like a multiple choice test where everything is in slope intercept form, all the answers are. But if I can, I'm going to do as little work as possible, because really College Board is only concerned about you getting the right answer. Okay, so write the equation of the line that's graphed. I know what my y-intercept is. My y-intercept is 1. What I notice is that from 1 I go up 2 and then over 3 to get my next point. So I can use this in slope-intercept form. So y is equal to 2/3 x plus 1. Okay, and that is slope-intercept form. If I wanted to do this based upon a table, then I do have to find the slope. I do want to make sure that this is linear, so I am asking, could this be a linear function? So I do need to check the slope between all the points. And so I get negative 10 minus 5 over 5. Here I get negative 25 minus a negative 10 over 5. And then this one here, I get negative 40 plus 25 over 5. When I reduce all of these, I get negative 15 over 5, which is 3. And it's a negative 3. And then I get here, same thing, I reduce, I get negative 3, and also I get negative 3. So because the differences are all the same, I do have a slope of 3. That is my slope. Sorry, negative 3. And then I was actually given in my table of values my y-intercept, which is 0, 5. So I can write this in slope-intercept form, negative 3x plus 5. If you didn't want to do it in slope-intercept form, you could just pick whatever coordinate point you wanted and do point-slope form. Okay. So question 11, I want to know what value of x is given here in this coordinate point. And I'm given that the slope is equal to 3. So if my slope is equal to 3, then the difference between these points, so the rate of change is what I'm looking for. So 6 minus 2 over negative 4 minus x, and I set that equal to 3. So I set my slope formula equal to what my slope is, which is 3. So I get 3 is equal to 4 over negative 4 minus x. I can cross multiply, so then I get 3 negative 4 minus x is equal to 4. And then I can distribute if I wanted to, or I can divide. I'm going to go ahead and distribute. So negative 12 minus 3x is equal to 4. Because I'd like to worry about working with fractions later if I have to, or maybe not work with them at all if I can. So this will give me 16 when I add 12 to both sides. So I get x is equal to negative 16 over 3. Okay. Few more, and then we'll be done. Okay, so let's go ahead, take a look at the next one. So 13. I'm going to use the intermediate value theorem. If you forgot what the intermediate value theorem is, go back and read the notes. So if you go back to the notes pages, you can look up intermediate value theorem. And I want to show that there's at least one 0 in the given interval. So what I want to do is I want to find f of 1. F of 1 is 1 to the 5th minus 2 times 1. So f of 1 is equal to negative 1. Then I'm going to find f of 2. Now, something important to note from your previous class, so any advanced math or pre-calculus class that you took before this, requires, well, that's a require. It shows you that you can use synthetic division to figure out what this answer is of f of 2. So just as a reminder, I could always do synthetic division. My coefficient of x to the 5th is 1. My coefficient of x to the 4th is 0. There's no x cubed. There is no x squared. There is an x, and there's no constant term. So I could use synthetic division, and whatever I get down here is actually going to be what f of 2 is. I do this sometimes when I just need, like a quick, answer. Arithmetic is a little bit less, but in this case, I think the arithmetic is easier if I just plug in 2 here. So it depends. Like if I have a really long polynomial, I would totally use synthetic division. If I don't have a long polynomial, like in this case, I would go ahead and just plug it in. So I have 2 times 2 here. So then my f of 2 is equal to 32 minus 4. So f of 2 is equal to 28. And yes, by the intermediate value theorem, since f of 1 is negative, and f of 2, which is 28, is positive, there must be at least one spot where the graph crosses the x-axis. And it's at least 1, 0 between x equals 1 and x equals 2. Okay, so now I'm going to look at some graphs just to get you guys, talking about maxes and mins and increasing and decreasing. So a minimum of the function is at negative 1. So the minimum is the y value. So it's at x is equal to negative 2. So be careful because I'm asking you for the minimum value. If I'm asking you for just the minimum value, and that is the y value. If I'm asking you for the value of x where you have a minimum, then I needed the x equals negative 2. So just be careful because you could speed read and then mess yourself up. Okay, and then my maximum is somewhere like between here. So we can just say, about 3.5, so about 7/2 here is the maximum. Where is the function? Increasing. Let's change colors here. The function is increasing on this interval here, and I do want it in interval notation. So that is approximately from -2 to 3/2. The function is decreasing everywhere else. So it's decreasing on those intervals. So that goes from -infinity to -2. I do need the little u for union. It does not look like a regular u. There's no little like tail at the end. And then this goes from 3/2 to positive infinity. Don't put the word and between there. This is interval notation. You must use the union between them. It asks you for the domain of the function, which is all the values of x, or the independent variable. So this is all real numbers. And in this case, the range is also all real numbers because there's no values of either x or y that are excluded. Okay. And then the last one I'm going to do is 17. So what's the minimum and maximum of the graphed function? So I do have some minimums. The actual like full like the when I ask you for a minimum, I'm looking for an absolute. So the absolute lowest point on the graph, which is approximately right here, which is maybe, it's not quite like -1.5, so maybe -1.25. So we would say -5/4. And there is a difference between an absolute and a relative, but we'll talk about that a little bit later. When I ask you for the minimum or maximum, I'm looking for the absolute, I'm looking for the bump that is the lowest. In this case, as far as the maximum is concerned, it goes on and on and on forever. So we could say that there is a relative maximum, because technically it goes on and on and on forever, so there is no maximum value. There is no absolute highest point because that would be infinity, and infinity is not a number. So we would say that there's a relative one at y is equal to 3. Relative meaning not, the absolute highest point, but there's like a little turning point where it goes from increasing to decreasing. Okay, so where's the function? Increasing, the function is increasing from -3 to 0 and from 3 to infinity. Oh, sorry about that. Okay, so -3 to 0 and 3 to infinity. Okay, and then the function is decreasing from -infinity to -3 and also from 0 to 3. Okay, what's the domain of the function? That is all real numbers, because I could have any value of x. But the range, however, notice that I don't go below, that -5/4. So my range is actually -5/4, closed bracket, because I can be equal to it, and then all the way to infinity, which is an open bracket, because I cannot be equal to positive infinity. Okay, and that gets you through the first problem set, all the odd questions. Now you go ahead and try all the even ones.